Okay, we're going to try this again.
Um,
We're on page 122. We're on section 2.7. And once again, we're working with just solving formulas in unit analysis. Okay? If that should go off, we're going to go on. Okay? But let me know. All right? So I want to look at just solving for variables when you have something like this. Solve 4m minus 3n equals 8 for m. This is the type that we're looking at, where we have more than one variable. And we have an m and we have an n, okay? So, we want to solve for m. So you got to keep it in your mind where m is. And you got to treat n like it's a number. Okay, that's the weird part, all right? So, we do the same thing. We start out, we change this to plus and negative. We change all subtraction to positive. And then we look at m. What happened to m? M is right here. It was multiplied first by 4, and then it was added to a negative 3n. You see that? So we reverse the order, all right? So we subtract a negative 3n from both sides. Now, there is no n's over here, is there? Okay? So some students write it off to the side. Some students put it over the 8 because they're not like underneath the 8. I'm just going to go right here. You can put in a 0n if you want, or you can just leave it blank. But what happens is we go plus a positive. So over here we have just 4m. Over here we have m, or 8 plus, and we do plus a positive, which is 3n. So we have both numbers over there. Do we see that? Is that still working? Okay, good. All right, now, we have not solved for m. We still have a 4 there, and it's multiplication. So we use the reverse, which is to divide by 4. The only thing is that we have to divide both these by 4. All right? So m equals, now I'm going to give you two options here. You can do 8 plus 3n over 4, or you can do 8 over 4 plus 3n over 4. And if you do it this way, it needs to be 2 plus 3n over 4. I will accept these two. I will accept this one, and I'll accept this one. Okay? Either one. And you might say, well, that's weird. That's not a normal answer. You're right. That's not a normal answer. Okay? It's an answer that involves variables. Okay? And it's not easy. All right, let's take a look at this one, number 2. 3x minus 2y equals xz plus 5 4x. This one's a little harder. Okay. Jackson, do you have questions about this? This number 1?
No.
Okay.
So our final answer on one is?
Your final answer is m equals, your final answer is m equals 8 plus 3n over 4, or m equals 2 plus 3n over 4. These are your two possible answers. And it needs to be m equals, because we're not solving for just a normal variable anymore. We're solving for a variable.
So we can't change it to x?
No, you can't change these to x. I'm sorry.
Okay.
Okay? All right, we're not just solving for one variable. That's when you solve for one variable, you can do that. When you're solving for a variable and there's other variables involved, you cannot do that. Okay?
What if we did x and y for variables?
No, don't do that. No, it just becomes a mess. I'm sorry. So you stick with what they give you. Okay, so on this one, we want to solve for x. So I'm going to change this to plus a negative. Is that okay that I do it in the original problem? We're okay with that. We're good now that we can do it. Here's the problem. X is in two places. X is in two places. If X is in two or more places, you have to put them together and move everything to the other side. Okay, now let me show you how that's done. Okay, first of all, I want to move this X over to this side, right? So I'm going to subtract an XZ from this side, because it is an XZ. But if I do it to this side, I gotta do it to this side, right? So I'm gonna do it out here, minus xz. Why do I do it out here? Yeah, I don't have any like with it. So I'm gonna squeeze a little 0xz up here. You can put that in there if you don't want to. I don't make you do it. Alright, but this is, I know a lot of you go plus a negative and plus a negative, correct? So now I have a negative xz plus 3x plus a negative 2y equals 5. Is that correct? Tyra, you're okay with that?
Yep.
Okay. So now I want these guys to be by themselves. Okay? It's kind of like friendships. These guys want to be by themselves. We need to get rid of this. All right? So I'm going to subtract a negative 2y over here. I'm going to subtract a negative 2y over here. Notice, Jackson, that I put it off to the side. If you want, you can put a 0y there. So you have something to subtract it to. That is up to you. Okay? All right. You okay?
Can you explain how you got that again?
Which one? This line?
Yeah.
I subtracted xz from both sides. I subtracted xz from xz, and I got 0.
Can you take 3x and do that with xz?
No, because xz is different than 3x.
Yeah.
So I took it from 0xz. I added a 0xz, and I took it from that. That's how I got this. All right. Now, I subtract, that's plus a positive and plus a positive. Is that correct? So this is gone over here. So on this side, I have a negative xz plus 3x. On this side, I have 5 plus 2y. Now, all the x's are on one side, and everything else is on the other. Say that again. Now, all the x's are on one side, and all the others are on the other. Are we good? Some people like to use the commutative property and rewrite these. So they put 3x plus a negative xz. It does not matter. Okay. All right. What I'm about to do is probably the scariest moment of this. Okay. I want to use a distributive property and reverse it. So I'm distributing out instead of in. What do both of these have in common? X. Right? So what I want to do is I want to factor out an x, leaving a negative z plus 3 on the inside. Now you know you can do it right if you put it back in and you get the same thing. This will be a negative xz plus 3x. Do you see that? Okay? We good? All right. Right? Braxton, what do we have in our mouth?
Oh,
Spit it out, please. No gum. Or no candy. You can have gum. You can spit it out. Okay? Alright. Now, we good? Now I have x all by itself. Alright? So I'm going to, what operation is going on between this and this quantity?
Multiplication.
Multiplication. What operation do I use to undo it?
Division.
Division. So I'm going to divide both sides by this quantity. You're dividing by a quantity now. So I'm going to divide by a negative z plus 3. And I have to do it on both sides. Do you remember last year in 7th grade when I told you to learn your integers quickly? Because we're going to move on to different things. We are here. So now this cancels and this cancels with that. And I have x equals 5 plus 2y over a negative z plus 3. And that is your answer. Whether you like it or not, that is your answer. Because the first question I usually get from students is that your answer? Yes. Because we're not getting a number, are we? We're getting a quantity.
Could you explain how you got from that line?
This line to this line?
Yeah.
Okay. All right, well, I'm going to go from this line above again. These two both have an x in them, so I distribute the x out instead of in, leaving a negative z plus 3. You understand?
Why wouldn't you have a negative x?
The negative, I took an x out. I left the negative 1 inside. This is a negative 1. Remember, you lazy Americans?
Yeah.
Okay, so the negative 1z is inside, all right? And then I want to get x by itself. Remember it said solve for x. So I want to divide. The operation between these two is multiplication. And so I have to divide this by itself. Whatever I do to one side, I must do the other. Okay? All right. Tirsa, you okay? All right. Caden, any questions?
I think so.
All right, we're going to do another one of those. Okay? Let's take a look at this one. 6q minus 18 equals qr plus, oh, I do not like the t, but they're using a t, for q. All right, once again, you cannot change the variables because the variables are kind of important. They're formulas. All right, so change all subtraction to addition. All right, you will notice that there are two q's, and remember I'm solving for q, there are two q's and they're on opposite sides. So I need to get them on the same side, okay? So I like them on the left, you can put them on the right, but I like them on the left. I'm going to subtract a qr from this side. You see that, Jackson? I put it right underneath the qr. But Jackson, there are no qr's over here, none
Yeah.
whatsoever. So I'm going to subtract it over here, and you can put a 0 QR right above it if you want to subtract it from. It doesn't matter. But since I'm subtracting, it's plus a negative, plus a negative. Do you get that? We good? All right. And so over here, I get a negative QR plus 6Q plus a negative 18 equals just T. The QRs went bye-bye, one subtract, the other is negative, right? Correct?
Yes.
All right, now, thank you for your yes. All right, now I want these two by themselves, because these two are the only two that have Q's. So I need to get rid of this guy before I do anything. And since I'm adding it, I have to subtract him from both sides. So I go minus a negative 18. I do not have any numbers over here. So I can put, if you want to add a 0, I don't need a variable, I just need a number, right? I can subtract the negative 18 from him. Is everybody good with that? All right, so now I do plus a positive. And I get over here, negative QR plus 6Q equals T plus 18. Now I have my Q's, they're together. Everything else is moved to the other side. And I use the distribute property to distribute the Q out. Instead of putting it in, I'm doing it out. So I pull out a Q, leaving what, Jackson?
QR. Or no, R.
And it's
Negative
negative, thank you.
Yeah.
Plus, and then what?
6.
6. Not Q, you took it out,
Oh, yeah.
remember?
Yeah.
And now I'm going to divide everything by what, Jackson?
By Q.
Nope, I don't want to ever divide by Q, that's what I'm trying to find.
Oh. Q to 18.
Nope, what's with the Q?
R.
Not just R. What's with the Q? What's on the side with the Q? Here is Q. What's on the side with Q, Jackson?
Parentheses.
Parentheses what?
Negative R plus 6.
All right. And what operation is going on between those two?
Distributed.
What operation is going on between Q and that?
Multiplication.
Multiplication. What operation do I use to undo it?
Division.
And what do I divide by? I want Q by itself.
Yeah, so.
What do I divide by? Did the same thing over here.
Q plus 6.
A negative R, no, there is no Q plus 6, bud. It's a negative R plus 6.
Yeah, negative R plus
Okay, you gotta be careful because Q and R are two different things. So I'm gonna divide by this. This cancels. So I have Q equals T plus 18 over a negative R plus 6. You understand that, Jackson? Yes or no?
Kind of.
Okay, you gotta get used to that. It's crazy. It is, but it's what it is. I can't change it. Kaden, you okay?
I keep writing the wrong thing. but
Okay,
yeah.
it's easy to do, bud. Okay, so sometimes we have a formula that we use. All right? Now, these are all special equations, but sometimes we actually have a formula that we use. Okay? So I am on page 123, and I'm looking at example 3, and it says use linear equation, literal equations. All right? And it says fitness. The formula to compute a person's body mass index is B equals. Okay? So, and it's capital B. Don't be changing the letters. It's capital B equals 703 times W over H squared. Does everybody see that? I'm in example 3 on page 123. Okay. So this formula is used where B represents the body mass index. W is the person's weight in pounds, and H represents the person's height in inches. Okay? It says solve the formula for W. It says solve for W. Okay? Solve for W. All right. That's W. Right? Okay. Now, let's take a look. There are two things that are happening to W. It's being divided by, or it's multiplied by 703, and it's being divided by H squared. Do you agree?
Two things happening to what?
W. Being multiplied by 703, being divided by H squared. So I want to undo both of those. You know what? I can undo them both at the same time, or I can take 2 steps to do it. Which do you prefer? 2 steps? All right. The first thing I'm going to do is I'm going to divide both of these by 703. Because I want to get rid of that. It doesn't matter. They're both multiplication and division. I can do them. Okay? So I'm going to divide by 703 here. I'm going to divide by 703 here. So I have W over H squared, because this cancels, right? Equals capital B over 703. Do you agree? Jackson?
Yes.
Okay, Ryan. Now I want to undo division. How do you, wait, question before we get to you. Yep.
If you divide 703 divided by 703, that's 1.
Yep, and 1 times anything is itself.
Okay.
All right, Ryan? I want to undo H squared. It's division. How do I undo that?
Multiplication.
I multiply by what?
H squared.
I multiply by H squared. I'm going to do it over 1 over here. Over here, I'm going to do the same thing. B over 703 times H squared over 1. Does everybody see that? So the H squares cancel over here, so I have W. I have achieved my goal. I've tried to get W by itself. And now I have B times H squared multiplying straight across divided by 703. All right? This is an actual formula. Okay? So, it says, what? Is everybody good? Now I'm going to look at the second part of this. I've solved for a formula. Now it says, what is the weight of a person who is 64 inches tall and has a body mass index of 21.45? What's a body mass? Which letter represents the body mass index? B. Capital B. And it's 21.45, so I'm going to put 21.45 in that. And how tall is this person? 64 inches. So I'm going to put 64 and I'm going to square it and then 703. That will tell me the weight of this person. Okay? Alright? So what I do is I take 64 and I square it times 21.45 and then I divide by 703. Tell me the weight of this person in pounds. You have a calculator? Ashley, did you get it?
Mm-hmm.
What is it?
124.8. It'd be 125.
If we round it, this person's approximately 125 pounds. It's kind of interesting. Now, I could have solved for the height. I could have solved for the body mass. I could have solved for all three of them. But this is what I chose to say. So you see that I can use literal analysis to get a letter and then divide, or use it to find an actual number. Did you get this, Tyra?
No.
64 squared times 21
Yeah, I got
point,
it.
okay, all right,
So on our assignment,
yes.
will we always have like those problems where it's x equals something over something, or will it have?
You'll have both. You'll have both. Did everybody hear that? He asked if we will have these where you just X, or will there be another question to it? Braxton, you with me?
Mhm.
Okay? Yes, you'll have both. All right. I have just a few minutes. Now, according to Mrs. Svensson, she says that she has taught you guys unit analysis. Okay? And I'm hoping that she has, and I'm hoping that you understood it. Because you will use unit analysis from here on out. You'll use it next year in geometry, right? We've already used it, haven't we? And so then you'll use it in science the rest of the classes. So you need to know it. It's not something that's going to go away, okay? So let's take a look on page 124. I'm looking at example 4. Example 4. I'm going to read it to you. It says a 10K run is 10 kilometers long. That makes sense, doesn't it? If 1 kilometer is 1,094 yards, use dimensional analysis to find the length of the race in miles. It says hint, 1 mile is 1,760 yards. So basically, we want to know, this is number 5, right? We want to know 10 kilometers. Now this is just is how many miles? That's the way she sets it up, correct? All right. So we start with 10 kilometers. You remember this? And she puts a line and she does this. What should go down here?
Be
We want to
One.
cancel kilometers, right?
1.
1 kilometer. And we need to change it to, it looks like we have yards. And yards are compared to what in the metric system? Meters. Thank you. Meters. So we want 1 kilometer is how many meters?
1,000.
1,000 meters, right? Is that right? 1,000 meters, right? All right, so now, what do we want up here?
Below you could put 1 yards.
Okay,
Maybe.
we want a meter down here, don't we?
Yeah.
So 1 meter is, does anybody know what 1 meter is? Oh, they tell you. Right there in the question. It's 1 point what?
0.94.
0.94 yards, right? Right? Very good. Now we got to keep our labels, right? Because we cancel them, right? Okay, so then we have yards. We got to have yards down here, and it told us that 1,760 yards is what? In the problem.
1 mile.
1 mile. And look, I have mile right here, right? And that's what I want to know, right? See how that works? The ending. Now let's cancel, all right? So this kilometer cancels with kilometers. This meter cancels with meters. And then these yards cancel with that yard. So what I need to do is, remember, she says take all the top, multiply it, and divide by the bottom. So we're going to take 10 times 1,000 times 1.094 times 1. We don't have times by 1. Divided by 1,760 because these are both ones. So how many miles approximately to the nearest, I don't know, let's go 10th. How many miles is it? If I take 10 times 1,000,
6.2.
it's 6.2. You should get 6.2 miles. Right?
Yeah, 6.2.
Okay.
6.2, but you drag it down to 6.2.
Okay. Now, I know we get out at 10:03. I'm going to give you tomorrow to work on this, but I want to do a problem from the assignment because it's a little bit different. Let's take a look at number 24 through 20. I'm going to do 25. This is, I'm on page 125. 125. Yep, you were on it. Page 125. Okay. Take a look at 24, 25, 26, those. It says select an appropriate unit for the choices below to convert the rate to that unit. I'll say it again. Select an appropriate unit for the choices below and convert the rate to that unit. We have the first one's feet per second, second one's miles per hour, the third one is millimeters per second, and the fourth one is kilometers per second. Do you see those little boxes? That's what I'm talking about. So let's take a look at number 25. Oh, I like this one. Okay. A snail is moving at 3.6 miles per hour. What do you think? No, that's meters per hour. Why do I know it's not miles? We're talking about a snail, isn't it? Okay. And what do you think we want to convert it to up there? Which one of those do you think? Do we want to go feet per second? Miles per hour?
Millimeters.
I bet why millimeters per second?
Because a snail doesn't move very
That's
fast.
right. A snail doesn't move very fast. We're going to do millimeters per second. Okay, now, do you guys realize that we have two labels? So we start with, don't we start with 3.6? I'm going to put meters. Is that okay? Because I keep wanting to put miles. And you know that a snail doesn't do that, right? Okay. So we want to go 3.6 meters per hour. We want hours up here, right? So they cancel, right? And meters down here, we can't get meters. 1 hour, right? 1 hour is, we want to change to seconds, right? How many seconds are an hour? Be careful here.
No.
Just 60 seconds.
60 minutes in an hour. And
3,600.
how did you get 3,600, sir?
60 times 60.
All right. Did you know that? That there was 3,600 seconds in an hour,
I did
right?
not.
Okay. All right. Okay, so now we got seconds, so we want to keep this label. So we don't want to cancel that, and we want to change to millimeters, right? So millimeters just go up in top here, and we want to cancel an hour, right? Or we want to cancel meters, right? Because we got seconds here. We canceled the hour right there. I should have done that. So we want to cancel meters. So we want 1 meter is how many millimeters? Because we want to change to millimeters. 1 meter is how many millimeters? You don't know how many millimeters are in a meter?
Wait.
There's 1,000, isn't there?
Yeah.
There's 1,000 millimeters in a meter. So now the meters cancel, and I'm stuck with millimeters per second, right? So I take 3.6 times 1,000 divided by 3,600. Let's round it. I don't know if you're going to be able to round this one to the nearest tenth. It's going to come out.
I got 1. Yeah.
It's 1. You should. He goes 1 millimeter per second. If he's moving. That's slow, guys. That was my 100 time. Okay? That's pretty slow. They had to time me in the 100 with a calendar. We're talking slow. All right? All right. So your assignment, not for tomorrow, is it? Not for tomorrow. Your assignment is page 125. Numbers 8 through 28 even. 8 through 28 even. Okay. We're just doing evens, but make sure that you might have to do an odd every once in a while to see how to do the even. Okay?